Hello everyone. In today's session, we will discuss about the dynamic routing and we will implement the RIP protocol that stands for the Routing Information Protocol. So we will learn about this particular protocol in this particular session. Okay. So basically this RIP protocol is one kind of distance vector routing protocol. So what happens in this? It provides the shortest path to reach to the particular destination with the help of hop counting. Now what is this hop? Whatever the intermediate nodes are there between the source node and the destination node, that is known as the hop. So the minimum number of hops are there, so that path will be followed to transfer any packet from one end to the another end. So on this particular basis, this RIP works and it is a dynamic routing protocol. So what happens if any link goes down due to certain problems or reason, so it will automatically update it routing table and it will follow the another path to reach to the particular destination, right? So we will configure this kind of thing. So for that we required three different routers. So I am going to take generic routers. Okay, so over here I have taken this three generic routers, right? And then I will also put the generic switch over here. Two generic switch we will use, so that in case if we want to add on some more PCs, then we can add, right? So right now for the demonstration of this RIP protocol, I'm going to use only one single PC. But if you want to take, then you can also use multiple PCs, right? So now I will just link each and every devices with each other. Okay. So over here you can see that this will use your fast Ethernet point, right? And whenever the same type of devices you are going to use, at that time it will use the cross connection, right? So this type of link will be there. So it will use your serial port, right? So second one, and this is the third one. So over here I have created the ring type of topology of this between these routers, right? So that if in future this particular link will goes down, so the packets can reach to this particular destination via this particular route, right? So for that I have provided over here two different routes. So over here there is hope count is only one, right? One node away, and over here there will be two. So this is your shortest path. So in the first scenario the packet should follow this particular path, and if this link goes down, then only then it should use this particular path, right? So now we will configure our PCs. So for the configuration we will just open the desktop. Let's say before starting with this, let's just provide some outlines so that we can be able to understand which are the different networks over here, right? So let's say that this is the so this is the one network, right? Let me just zoom out, right? Then this will be your second network, right? Then let's say this will be your third network. Then this will be your fourth one, and this will be your fifth one, right? So let's just say that this will be, let's say, 10.10.10.0 network. This is your 20.20.20.0 network. This one is our, let's say, 192.162.10.0 network. This one is 192.162.20.0 network, and this is the 192.162.30.0 network, right? So now we will just configure these things. So this is in this particular network. So we will provide the IP address as 10.10.10.2. Okay, because we will provide 10.10.10.1 for the gateway. That means the router of this interface will have 10.10.10.1, right? Similarly, I will provide the IP address to this particular thing. So for that, 20.20.20.2. Okay, then this 20.20.1. Okay, so we have configured the two PCs. Now we'll configure this particular router. So in the command line mode, we will configure this particular router, right? So in this, first of all, we will write enable. Then we'll enter into the configuration mode. So configure terminal. Then to enter into the interface mode, we will write interface fast ethernet 0/0, right? Then we'll provide the IP address. The IP address for that port should be 10.10.10.1. The subnet mask for that is 255.0.0.0, right? I will enter it and then no. Okay, so we have basically configured this port, so you can see that this becomes green. So this is perfectly fine. This interface configured perfectly, right? Now over here we are also having two different interfaces. So let's just see which interfaces are this. So this is serial number 3 and this is serial number 2. So we need to configure serial number 3/0 as a 192.162.10.0 network, right? So what we will do, we will just enter into the interface, that is serial interface, that is the this was the third, right? So we'll enter into serial 3/0, and in that we will provide IP address, that is 192.162.10.1, right? 10.1, and for this subnet mask is 255.255.255.0. Will provide no shut to turn on the switch of that particular interface, right? Then we'll exit from this interface and we'll enter into the interface which is having serial number 2/0. Okay, and in that we will provide the IP address, that is 192.162.20.1, because this network is having 20.0, right? So we'll provide 20.1 and then 255.255.255.0, and then no shut, and we'll exit from this. So we have configured this particular router. Now we'll configure this particular router. In this particular router, you can see serial number 2 is having 20 series and serial number 3 is having the 30 series network, right? So we'll enter into the CLI and then we'll enable configure terminal. We'll enter into the interface, that is the serial, then 2/0. So as we know that this 2/0 is this one, so we'll provide the IP address 192.162.20.1 is already given to this point, right? So we'll provide 20.2 and 255.255.255.0 and no. You can see this will become the green, right? So we have configured this point very finely. right? Now we'll just exit from this and we'll enter into the another serial port, that is a 3/0. In that will provide the IP address 192.162 dot. Now this is our 30 series, so we'll provide 30.1 over here, right? So 30.1 in 255.255.255.0 and no shut. We'll simply exit from here. So now we have configured these two routers. Now the turn off this particular router. So you can see that this is using serial 3.0, right? And this is with the help of 2.0, right? So we'll configure first of all, enter into the enable mode, then configure our terminal, then interface mode in a serial 2/0. In 2/0, it is connected with this particular network. So we'll provide 192.162.10.2, right? So over here we will just write IP address 192.162.10.2 255.0.0. Sorry, this is class C, so 255.255.255.0, and we'll say no. So we have just turned on this particular router, right? So here is the perfectly fine configured topology. So you can see the green lines over here. Now we'll do for the another interface. So interface serial 3/0, and thus we provide IP address, that is 192.162.30.2 255.255.255, and we'll just no shut. So now you can see that we have configured each this 2 points, right? Now there is a requirement to configure this particular port, that is the fast Ethernet port, right? So for that we just need to enter into the interface mode, that is the fast Ethernet 0/0. In that we need to provide the IP address, that is 20.20.20.1, and for that the subnet mask is 255.0.0.0. Will enter and no shut. So you can see that all over in this topology all the lights are green, right? So we can say that we have configured our topology perfectly and all connections are working fine, right? So to check that, we just put the packet over here and another one over here, and you can see that the successful, right? So this router is connected with this one. If we want to check for this one, it will be successful, but if you want to transfer the packet from this and to this and, it will fail, right? Why that so? Because so far what we have done, we have only given the configuration, we have done the configuration of all the devices, but this router don't know about any other networks in this particular topology, right? So what we need to do, we just need to provide the information about all other networks which are in this particular network topology, right? So for that we are going to use this RIP protocol, right? So for that what we need to do, we'll just open this thing. In the configuration mode you need to write router RIP. That means we are just entering into the routing mode, right? And over here we are using the routing protocol, that is RIP. So we have entered into the RIP routing mode. So in that what we need to do, we just need to provide the network information through which network information. So this router is directly connected with whatever the networks, right? So we just need to provide information regarding that this particular router is connected with these three networks, right? So first of all, for defining we need to use keyword network, and then we'll provide the network ID, that means 10.10.10, sorry, 10.0. So this is the one network. It is also connected with another one, that is the 192.162.10.0, and it is also connected with network 192.162.20.0. Okay, and we'll just exit from here. So now we have informed to this particular router that these three are the networks which is directly connected to you, right? After that, the same thing we will do with this router 2 also, right? So in the configuration mode, we will enter into the RIP mode first, routing mode, right? And that will provide about the information regarding the network, which is directly connected to this particular router. So for this router, 192.162.20.0 is directly connected, and another one is 192.162.40.0, right? Okay, okay. I just there is one spelling mistake over here, so I just correct it, right? And then exit from here. Now for this thing, router RIP, then network in that 20.20.20.0, sorry, network, then network 192.162 dot, this is directly connected with 10 number, right? So 10.0, and it's also connected with this 30, so 30.0, enter and exit. So now we have configured this particular thing, and now we'll just check that what is happening with the packet. So first of all, I will just clear the scenario. Now I will put one packet over here and one packet over here. Now you can say it is successfully transmitted. But how we will able to understand that which path it has used? So for that, what we need to do is we just need to click on this, open your command prompt and use the command press root, press RT, and write down the destination address, that is 20.20.20.2. Enter. Over here you can see, first of all, your source address is this one. So from this one it reaches to this particular router, right? Because this router is configured as a 10.10.10.1. Then you can see that 192.162.10.2, right? So this 10.2 is this one. So it reaches over here, and then it reaches to this particular destination, right? So you can see that over here it has used the shortest path, this one. This is your shortest path, right? But let's assume that because of some reason, what happens, this link goes down, or you can say there is no connection between these two links now, right? So now what happens if I want to transfer the packet from this end to this end? Does it work? So let's check. Yes, it is. You can see that over here it's showing you the successful transmission, right? So now let's check which paths it uses, right? So we'll enter it. Now you can see that it uses 20.2, right? So this 20.2 is this part, right? Then 30.2, this is the 30 series, right? So 30.2, and then it reaches to the destination. So as it comes to know that there is no link between these two nodes, these two routers, right? So it automatically updates its routing table and updates the path and use that particular path. Now, if you will add that part again, right? And now if you will just transfer the packet, it will successful. And now let's check which path it is using. So now again you can say it uses the shortest path, that is 10.2. So this is the basic idea behind this RIP, routing information protocol, and this is the way this dynamic routing works, right? So it reduces the work of human, because this router itself identifies about its neighbor information, learns from the neighbors routing tables and updates its routing table accordingly, and it checks within 120 seconds, each and every after each and every 120 seconds it checks the routing tables, The each and every node communicate with each other, and then it updates its routing table, and accordingly it follow the path to reach to particular destination. So this is the routing information protocol, right? So this all stuff you can also do with the help of this config, this user interface also, right? So in this RIP is already given, so you just need to add your network through this. You just need to write down your address and it just click on add, so it will add into this, right? So yeah, that's it from today's session. And the next session we will also learn about the OSPF protocol and how that protocol works. Thank you.